And welcome back. And we're back to the difficult GCSE questions. I think this one's quite a challenging one because on the face of it, it doesn't appear to actually follow the normal rules, does it? That we teach in class and tell you that you have to do all the time. I don't really want to say any more. I want to let you think about it for a little bit. As ever, pause the video, give it a go, and I'll go through it in a minute. All right, so how do we do? Now, this is one of these things, a bit like if you see a number like 256, I'd hope that you think that is 16 squared, or maybe even 2 to the power of 8 or something similar, but you recognize the number has certain properties. That's the whole point of this question here, is you can see, hopefully straight away, that I've got a base number of 2, I've got a base number of 5, I've got a base number of 10, and I've got a base number of 20. And while they don't all have the same base number, i.e. they don't all go to a 2 or a 5, they do go to a mix of 2s and 5s. And what I mean by that is 10 is the same as 2 times 5, and 20 is the same as 2 times 2 times 5. And that's the property I'm going to use now. Now, I will say this every now and then when I do these harder questions, which is quite often you're just doing something and frankly crossing your fingers and hope it's going to work. And that's a bit of what's going to happen here. So let's just switch these over. So 10 is the same as 2 times 5. So it's going to be 2 to the power of 4n times 5 to the 4n. So I've expanded the brackets in one go. I've already got that 2 is, well, let's expand this. So it's going to be 3n squared minus 15n. And 5 times 2 to the 1 minus 2n, again, let's expand the brackets, that's going to be 5 times 2 minus 4n. And all of that's divided by, well, I'm going to write this bit out because this is the bit that's easy to mess up. So 20 is 2 squared times 5, and all of that is squared. Let's try and tidy some of this up. So the numerator, let's collect my 2's. So I've got 2, 3n squared minus 15n plus 4n is minus 11n, and that's all the 2's I've got. And then 5 is going to be 4n minus plus 2 minus 4n. Now, when I'm doing one of these questions, I'm actually already feeling a little bit better because I can see that 4n minus 4n cancels out, which makes the 5 a little bit easier, because I did wonder how I'm going to solve this with two different n's in different places. Let's tidy the bottom up. So I've got 2 squared squared, which is 2 to the power of 4, and I've got 5 squared, which is 5 squared. Again, I'm not working out any of these numbers. I'm keeping them all in powers because I'm hoping that they're going to cancel out or give me something nice and easy to do. Okay, let's try and tidy all of it up in one go. So just look at the 2's. I've got 2 to the 3n squared at the top, minus n at the top, and then because the 4 is on the bottom or on the denominator, I take away the power because I'm dividing, so it's 3n squared minus 11n minus 4. And the 5's, well, I've already agreed or accepted that 4n minus 4n cancels out, so that's just going to be 2 minus 2, and of course that makes sense because 5 squared divided by 5 squared is just 1, which in other words means that doesn't go to 0, but it goes to 1, because anything to the power of 1, anything to the power of 0 is just 1. And remember, the question itself tells me this whole equation is equal to 1. Now, let's again think about what we know about numbers. I'm multiplying two numbers together. So I've got a number times a number is equal to 1. This number is 1, so it must be the case that this number is also 1. And if that number is also 1, it means the power must be 0, because I need to get anything to the power of 0 is always 1, so therefore the power must be 0, which means I have an equation that 3n squared minus 11n minus 4 is equal to 0. Can I factorise it? Well, I can actually factorise it, but let's just pretend I can't for a second. Let's do the slightly long route so we can do some different methods. So that means that n is going to be equal to 11 plus minus the square root of 11 squared, which is 121, minus minus 4, which is 16, times 3, which is 48. I'm going to divide all that by 2 times 3, which is equal to 6. Now, again, little things here make me feel a bit more confident. So first of all, 121 plus 48 is 169. And I know the square root of 169 is 13. So again, I'm feeling like I'm doing the right thing. It doesn't mean I am, but I'm definitely feeling a little bit better. So my solution is going to be 11 plus 13 over 6 and 11 minus 13 over 6, which go down to 11 plus 13 is 24 divided by 6 is 4. 11 minus 13 is minus 2 divided by 6 is minus a third. Now let's check the question again. Find the values of n such that. Doesn't say anything about n being positive, doesn't say anything about n being an integer. Any values will work, which means both these values are true, which means that n is equal to 4 or minus a third. And that is this question done. I think it's a pretty difficult question, but equally a little trick in there which makes it notably easier. And actually it's a very well set up question because it cancels out quite nicely. It looks horrific, works out quite well in the end. As ever, do leave a comment below, like, subscribe to the video, and I will see you for the next one. Thanks all.